Hello, my name is PV Sairam Sakir. Today I will going to teach one of the very important AML concept, that is this CNN, which stands for Convolutional Neural Network. So before studying what is CNN, we should know like what is the need of CNN. Why the requirement of CNN came for image dataset. So to understand this, first we will going to see this particular topic where we will study about what is the need of CNN. Then we will study what is the CNN and we will study these concepts like what is kernel, what is stride, what is padding, what is pooling, what is flatten, and how it is sent to ANN from flatten layer. And after that we will going to study the backpropagation in CNN, like how backpropagation takes place, how the weights are been updated, how the kernel is been updated. We will going to see in this particular lecture. And this CNN is very important for computer vision also. So that's why we'll going to study these topics in detail. So first topic comes why there is need of requirement of CNN. So for this I will take one example. So the example that I want to cover is, let's say I am having an image of size, let's say 1000 cross 1000. Like we have different type of images, right? 1080p, 720, 480p, like that. Here I am having, let's say 1000 cross 1000 image, p image is there. Okay, now and it is having the color channel as 3. Now what is color channel? The color images that you see when you take photo, you see different colors, right? Like here you are seeing this video in this particular blue color is there, black color is coming, white color is there. So you are seeing different colors. So that is why this when you put color channel as 3, it means that you are putting all the colors. To see all colors, like RGB colors is nothing but your color channel. Simple terms I will say, where combination of all of this leads to the all the colors. So that's why if color channel is 1, it means that it's a black and white image. Color channel 3 image, it's an RGB image. And you know, right, RGB is range from 20 to 255, where the 0 represents black and 255 represents the white. And combination of all three leads to formation of white. So now one very important thing I want to tell is, now see, image is divided into different pixels. You know, image is divided into pixels. So image divided into pixels. So since it's a color channel, so one color channel has, like, it takes 8 bit of storage. So here we have 3 color format. So 3 color channel. So it means it's a 24-bit storage it will take. That is 3 bytes. As 1 byte equal to 8 bits. So 3 bytes it will come. So 3 bytes of storage it will take for one single pixel. So now here we will solve this particular problem. Now you have to calculate how much storage is required for one particular neuron to do. So for this you have to solve this particular problem. The problem first you have to find is how many input channels are there. Like what is the total input power? So here I will write total input. So to calculate the total input, what we have to do, this 1000 into 1000 into 3 we will do. Okay. So once we done 3, what will happen? You will get some value, that is 3 into 10 to the power of 6 you will get the value. Correct? You will get 3 into 10 to the power of 6 value you get. And now when you pass this total input, that is required for this particular image is 3 into 10 to the power 6. Now, you know that when we pass an image to the neural network, it will have to pass through the hidden layers. Correct? It will pass through the hidden layers. So let's say here we are assuming 100 hidden layers. Hidden layers, let's say we are assuming it to be 100. Okay. So 100 we are assuming. So now to calculate the total number of possibilities, total number of possibilities will be 3 into 10 to the power of 6 multiplied by 100. So that will be 3 into 10 to the power of 8. Correct? But you already know that here we are having this storage. Like if we take about storage, each and every pixel will take 3 bytes of storage. Storage will be, let's say, 3 bytes. So now if you multiply 3 into 10 to the power of 8 into 3 bytes, so what it is getting you, if you multiply it with the storage, you will getting 9 into 10 to the power of 8. Correct? So when 9 into 10 to the power of 8, so what it means, you will take 0.9 and you will get 10 to the power of 9, which is nothing but equal to 900 MB. So for one particular image, it will take 900 MB of your computer storage. Sorry, 900 MB or 0.9 GB. Anything is same. So now you are seeing like how much computational power is required to process one particular image using the ANN. So that is why this 0.9 GB amount of data, like 900 MB of data is been consuming to process only one image. So that is why we won't be using the ANN concept. That's why the concept of CNN comes. Now, one more challenge is, let's say you are having 10,000 to 20,000 images you have. If you want to do process, here one image is taking 900 MB of your storage. So if you multiply 900 MB with 10,000 images, you don't have that much storage capacities in your system. And to create such storage requirements for our system will take high computational power. So that is the reason why there is a need of separate neural network which basically deals with the images. So that's why the concept of CNN comes. This is the challenge of ANN. So first what we did, we taken an image, it's a color image we took, and then you know that image is divided into different pixels, combination of pixels will form the image, and you know that one color channel will take 8 bit of storage. Since it's a 3 color channel, so it will be 24 bit, that is 3 byte. So now what will we do? You have to check the total input required for your neural network. So the total input is 310 to the power of 6. But you know, when you pass the input to the neural network, what will happen? You have to pass through the hidden layers. So here we are assuming it to be 100 hidden layers. We are assuming. So when you multiply it with this thing, you will get 3 to 10 to the power of 8. But you know that this every pixel will take 3 bytes of storage. So when you multiply it with 3, you will get 910 to the power of 8. So here 0.9 to 10 to the power of 9. As 10 to the power of 9 means GB. So that's why 0.9 GB, like 900 MB of data is being stored here. So that's the reason we won't be using ANN in this case. So we have to use CNN. So now what is the need of, what is CNN? I hope you understood this example, that why we won't be using the ANN for this particular images. So now we are going to study about the CNN. What is CNN? What is CNN? So CNN is a neural network concept which is basically used for image processing, object detection, and all the tasks where images plays a very important role in training the model. There you will be using the concept of CNN. It is very important for computer vision, very important for object detection, very important for image processing. Everywhere this CNN plays a very important role. So what CNN does? CNN uses the concept of filters. Concept of filters. Concept of filters, which is also called as the kernels. So what is the meaning of filter? To reduce the size of the image. Let's say we are having 1000 cross image. To reduce the size to 32 cross 32, from 1000 to 32, but at the same time preserving the important features. So to achieve that, we should use the concepts of filters and kernels. This is how your CNN plays a very important role in dealing with the images. So what is filter? To compress the image. To compress the image. But at the same time preserve the important information. Preserve important information. Okay, so this is the major objective of using the CNN. So now the topics that are plays a very important role here is, topics that we are going to study here is, first we have to study about the kernels. Second, we have to study about the strides. Then we will deal with the padding. Then we will deal with the pooling. Here we will deal with max pooling and average pooling. Then we will do flattening. Then we will send it to ANN, like we will send it to the neural network. So what we are doing in CNN actually is, you are having a particular image, okay? So instead of passing the entire image, you compress the image. That small compression image will be sent to the ANN. This is the basic idea behind the CNN. You compress the image, you only want important information, that you will send to the neural network. That is input, then hidden layer, then output, what we said in ANN, that we will going to pass. After flattening, we will send it to the neural network. Then we will study about the very important topic, that is backpropagation. Backpropagation. So these are the topics that we are going to cover in this CNN. So let us take an example to solve the particular problem for this CNN, and how CNN is important in image processing, that also we will study now. So let's start it. So now we will take this particular example and we will solve the important concepts of CNN and how we can able to compress this image that we are going to CNN. See, obviously 720 cross 720 image I cannot draw here because it's a very huge image. It won't come under this board also. So that's why I took one small image of 5 cross 5, and now here I will be using the kernel filter. So what is this kernel do? This kernel plays a very important role in identifying the important feature from the image. So to find the important points in the image, we will be using this concept of kernel. So now what does this kernel will do? So this kernel, we have to put it on the input image. We have to put it on the input image. Okay, let's put on the input image. Put on the input image. So how you will put it into input image? You have to take first 3, like here what is this thing, 3 cross 3, right? So how many 9 elements are there? So you have to select 9 elements like this. So you will select this particular thing. So now you have to put this kernel on this part of the image. And after putting it on image, then what you should do? You have to apply the dot product. Dot product. You have to do dot product. So in simple word, what is kernel doing? Kernel is trying to extract the important feature. Extract the important feature. But at the same time, what kernel is doing? It is extracting the important features and it is also reducing the size of input image. using the size of the input image. Like compressing the image it will do. So these are the two important points that you know about the kernel. So now what you have to do, you have to multiply this kernel on the input image and you have to do the dot product. So how to do the dot product? So here we will take 3, 3, 2, 0, 0, 1, then 3, 1, 2, and here you have to do the dot product. That is 0, 1, 2, 2, 2, 0, 0, 1, 2. So how will you do the dot product? First you have to do 3 into 0. Okay, 3 into 0 plus 3 into 1 plus 2 into 2 plus 0 into 2, 0 into 2, 1 into 0. Means it will come 0 only. If you add also it will come 0 only. So 0 plus what you will do here, you have to do 3 into 0 means 0, 1 into 1 means 1, 2 into 2 means 2. So 1 plus 4. Okay. So now if you sum it, 3 into 0 means what? 0 will come 3, 4, 3 plus 4 plus 5. So now 3, 0, 3, 1, 2, 2, 4. 0, 0, 0, 3 into 0, 1 into 1, 2 into 2. So 1 into 1, 2 into 2 means this. So what this you will get the total as 12. Correct. So now you got the first value of the new updated matrix. You got the first value of the updated matrix. So the first updated matrix value you got is 12. Now what you have to do? Now you have to, like, for only one matrix we did. Now you have to do for the other matrices also. So what you will do now? Now you have to select this particular kernel. 3, 2, 1. This particular kernel. And this kernel will do multiplication on this particular thing now. So how the multiplication takes place? Same procedure. 3 into 0, 2 into 1, 2, 1 into 1 this. You have to multiply this thing. So once you multiply this particular thing, you will get the answer and you will update here. So this is how the procedure takes place. So then what will happen? It will go like this. After doing this, it will go like this. Okay. So now after doing this, it won't go 1, 3, 2 because here only 2 are there. It is not matching this 3 cross 3. So that's why now you will go downwards. In downwards, what will you select now? In downward, you will select this particular thing now. You will select this particular thing. This particular kernel you will select. This particular matrix you will select. You will multiply it with the kernel. Then you will select this particular matrix along till 3. You will calculate. Then you will select this particular thing. You will calculate like this. So after completing this, what will happen? It will come down and you will do this particular thing, then this particular thing, then this particular thing. So after multiplying all of these things and doing the dot product and taking this sum, you will get this full matrix. So now I will write all of these values and will come. So here I wrote the values of this particular matrix here. So now you are seeing, like, here we calculated this particular thing, we done the multiplication and we got the answer for this multiplication thing. So now you can see that here in first row you are doing 3 things, 1, 2, 3, correct? Then you go to down, you do 1, then second, then third. In the third you are doing 1, 2, 3. So total how many elements will come? 9 elements will come. So that means 3 cross 3 matrix will form. Understood? This value, one value, then this multiplied with this, you will get this value. Then this multiplied with this, you will get this value. Then you will go down, you will multiply, you will get this value. Then center one, you get this. Then this one, you will get this value. Then you will take down and you will multiply it. So this is the updated matrix that you got. Updated matrix. So here if you observe, from 5 cross 5 image we compressed it to 3 cross 3. So you understood how the CNN works. So now in this 3 cross 3, what we have done? We have compressed the image using this particular kernel or filter, and we compress the image. At the same time we are preserving the important information in the image. So now after doing this updated matrix, this 3 cross 3 came. So can we derive a formula from this? Yes, we can derive the formula. So what is the formula for this? So let's say this input image I will represent it as I, this kernel we represent it as k. Okay, so and this particular, so the formula that we generate is n minus k plus 1. This is the formula that we generated. So now if you take example here, what is the size of input image? 5 cross 5 means 5 it will come. K means what? Kernel. What is the size of kernel? 3. So minus 3 plus 1. So this sum you got is 3. So 3 means 3 cross 3 matrix. So this is how the formula of to calculate this particular concept works here. So this is the first concept that we discussed now. That is understanding the kernel and how the multiplication takes place here. Correct. So now the next concept of stride comes here. So what is stride here? Now what is stride here? See, in the stride what happens, I will take one very simple example to explain what is stride here. Now let's say here I am having this I will take one small example to explain this concept of stride. Here let's say you are having 1 2 3 4 5 6 7 8 9 1 2 3 0 0 0 1. Here we are taking, let's say this is the input image you got. Okay, input image, and here using the kernel as let's say 1 0 minus 1 0 0 0 minus 1 0 1. This is the kernel that say you are using. This is the kernel 3 cross 3. So what does this stride do? See, here you saw in this above example, right? From this it will go to the next layer, then it will do the multiplication, then from 2 it will go here and it will take the multiplication, then it will go 1 down and it will do the multiplication and all. But by using the stride, what you can do is, let's say here you have selected this, here I'll add one more layer also of thing, let's say 5 0 0 1. Let's say this I added. This is let's say 5 cross 5 matrix. Okay. Here also adding 0 0 0 1 1. Okay. So now this is the 5 cross 5 matrix, right? So what does this concept of stride do? Here I'll write stride here. Stride does. So what does this stride does? Here this particular 3 cross 3 will go here and it will multiply here. Correct. See, by default in the above case we kept the stride value as 1. What is the meaning of stride equal to 1? Means after this particular matrix get over, it will go to the next matrix. Correct. But every time I don't want to go to each and every matrix. I want to skip one matrix. So for that I will be using stride. Let's say here I am doing this. Here we will multiply this particular thing with here. But after completing of this, instead of going to second one, if I keep let's say stride equal to 2, it means it will skip one particular next one and it will start from 3. This thing. Then you will take this matrix and you will multiply it with kernel. Correct. Similarly, what will happen? From bottom also it will skip one. Bottom also it will skip one, and this matrix it will take, and this matrix you will multiply it with the kernel. Similarly, you will skip this particular thing, and here you are doing this particular thing. You are multiplying with this matrix. So what will be the outcome of this? Here you will form a 2 cross 2 image. So here you will form a 2 cross 2 image. So let's say here you are multiplying 1 minus 3, 1 minus 3. Then what will happen here? Then second row will be fully 0. Then we'll directly do here minus 9. Minus 9, here 0 plus 2. So what will be the sum? Minus 2 minus 7, this will be minus 9 here. Got it? Then what will happen? You will take this particular example. 3 minus 5. 3 minus 5. Then here this will be 0. Minus 2 here you will get. So here you will get minus 4. Minus 4. So like this, these both values also will be solved like this. Here let's say 9 minus 2, 7 you will get here. And here you will get 2, 0, 0, okay. 0, 0, 0 you will get. So 2. Then here you will get plus 1. Here you will get 3. So this is how this particular, using stride you can able to calculate this particular thing. The advantage of using stride is you don't need to do this complex calculations. But one drawback of stride is sometimes the important information may be compromised because we are compressing the image. So from this, can we generate a formula? Yes, we can generate a formula. What is the formula that we are going to generate? The formula is very simple. Let's say this stride, I will represent it as S, let's say. The formula we will generate is n minus kernel k by S plus 1. This is the formula that we are going to generate. Now here, what is the n here? N is your input image, this is 5. So here we will take 5. What is the kernel size? Minus 3. So what is the value of stride that we kept? 2. So here we will do plus 1. So 2 by 2 means what? 1. 1 plus 1 means equal to 2. So this is how you got the value as 2 cross 2 in the stride. I hope the concept of stride is clearer to you. Correct? So now comes the next topic, that is padding. Padding is very easy. It's a 1 second topic. So this stride is over. Now we will discuss about the padding. We'll discuss about the padding. Padding and pooling lecture. Pooling is very easy. Only these two are complicated. Now third comes is padding. So what does padding does? I will take one example here and I will try to explain. Let's say 1, 2, 3, 4, 5, 0, 1, 0, 0, 1, 1, 2, 3, 0, 0, 0, 0, 0, 0, 1, 3, 0, 0, 1, 2. Let's say this is the 5 cross 5 image, and here we are going to take the same matrix. 1, 0, minus 1, 0, 0, 0, minus 1, 0, 1. We are going to take this particular 3 cross 3 matrix. Okay. So now what will happen? So here what you will going to do here? First you will go and you will multiply this particular thing. Correct? You will take this particular thing, then you will multiply. And now let's here I am assuming stride to be 2 here. Okay. Stride I am assuming to be 1, let's say. Let's say we are assuming 1. So now after doing this, what will happen? You will take this particular matrix and you will do the multiplication. Correct? Then you will take this particular row and you will do the multiplication. Correct? But did you observe one particular thing? Like here also I will go, then it will go down and it will, this multiplication will take place in the bottom side. Here we are going to take this particular bottom side. Here you observe one thing. This 1 is being used only once. 1 is being only used once. Only used once. Similarly, 5 also that we are going to choose, it will be used only once. This 0 will be used only once. Sorry, not this 0. This 3 will be used only once. This 2 will be used only once. But this 3 is having very important feature. It is having the maximum value, means important feature is there. So what is happening if we don't use padding? The important features are been dismissing from the input image. Like we are compressing the image, right? In compressing the image, we are losing the important information. So to prevent this particular loss of information, we will use the concept of padding. Okay, this padding problem is also called as border problem. Border problem. So what we will do in padding? See, here you got this particular problem. You will just do one thing. In above you will add zeros. 1, 2, 3, 4, 5, and then in the left hand side also you will add zeros. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Here you will add one more 0. 0, 0, 0, 0, 0. So now what is happening? Now if you take this matrix and if you multiply with this particular thing, it will take this particular matrix. Now the advantage is the important feature 1 is being using here. The border problem is being solved. So that's why whenever you use padding, you will add zeros in the up, bottom, left, right, you will apply these zeros. So that is why your padding plays a very important role in preserving the important information. So now how? So from can we use the particular formula to calculate padding? Yes, we use the formula to calculate padding. So the formula to calculate the padding is I minus k plus 2p. Let's say padding, I will represent it as 2, let's say 2p by s plus 1. This is the formula to calculate the padding. I minus 2p by s plus 1. This is the formula that we will going to use for calculating the padding. Here we will be using this thing. So now let's say here I will take padding is equal to 1. Padding is equal to 1 means applying zeros in only for one time. Padding is equal to 0 means you will apply one more 0 in the this thing, and you will increase the size of the matrix. So if I take padding is equal to 1, so what is my input size image? 5 is my input size. What is my kernel size? My kernel size is 3. What is the padding? 2 divided by what is stride value? Here I kept the stride value as 1 plus 1. So what will be your value? 2 plus 2 4 plus 1 5. So what is happening? 5. So you will the resultant after doing this particular multiplication of all the dot products, you will get a 5 cross 5 matrix. You get a 5 cross 5 matrix. This is how padding is calculated. You will calculate this particular thing like you will calculate this, but you will take this particular matrix. You will calculate with this particular thing. You will get, let's say, one value. First one is 0. You will keep the values directly 0. 0 1 2 is the second value. 0 0 0 1. So you are getting only 1. So your first value will be 1. Then you will take this particular thing. Here you will take the multiplication. You will get some value, you will add here. Like this 5 cross 5 matrix will form. Okay. So I hope the concept of padding is also been clearer to you. Now next topic comes is pooling. I am using this example only, okay, for pooling, because pooling is very easy approach to use. It's not that difficult. So what is pooling now? What is pooling? So what is pooling now? In pooling, what will happen? So first I will write this answer of this particular matrix, that is the 5 minus 3 plus 1 3 cross 3 matrix that will get right. I will write that and I will come back to you. And so here I wrote the result of this particular matrix that we got, that is 3 cross 3 matrix that we already calculated. So now what is the meaning of pooling? You got this 3 cross 3 matrix, right? But to further compress the image and to further preserve the important information, we will be using the concept of pooling. There are two types of pooling that we have. One is the max pooling, one is the average pooling. So what is the meaning of max pooling? Let's say here I want to do pooling for 2 cross 2. Let's say here I want to do pooling for 2 cross 2 pooling. Okay, 2 cross 2 pooling. What is the meaning of 2 cross 2 pooling? Means in this particular matrix you have to select 2 cross 2 elements. What are 2 cross 2 elements? Only this particular element is there. Then here you don't have any 2 cross 2. Below you don't have 2 cross 2. Only this one particular element is there. So here what is the maximum value that you get? You got the maximum value as 19. What is the meaning of average pooling? See, out of these 4, what is the maximum value? 19 is the maximum value. So max pooling value will be 19. So what is the average pooling here? You will take the average of all of this. Means you will take the mean of all of this. 10 plus 17 by 4. Here you will get 27, 39. You will get 39 plus 12, 51 by 4 you will get. So this is the value that you get here. That is some 12 point something you will going to get. This the value of 12 point, let's say 1 you getting. So this particular value will be the average pooling value. Now you might be a little confused, right? For 3 cross 3 matrix we done. What happens if we have big 5 cross 5 matrix? So for 5 cross 5 also we can calculate the pooling. It's not that difficult. Here we will add 2 more elements here, and below we will add 2 elements. It become 5 cross 5. Here we will add this pooling here. 1 2 3 4 5 6 1 0 2 3 4 5 6 7 8 9. Let's say we are taking this will be a 5 cross 5 matrix. Now you have to apply 2 cross 2 pooling. So first you will select this, obviously you will select this element, then you will select this particular element, then you will select this particular element, then you will select this particular element. Now what will happen? You see, now if you apply the max pooling here, what value you will get? In this search the maximum value. What is the maximum value? 17. 17 you will get. In this what is the maximum value? 19. So you will get 19. 19 you will get. Then you in this what is the maximum value? 9 you get. So 9 you get. In this what is the maximum value? 14 you get. So like this the maximum pooling works. So what is the average pooling now? Average pooling now. See, average pooling means here you take the average of all of it. Like here we got this value as 51 by 4 you got, let's say. You will get some value as 12.1, 12.2. Here you will get 18 means 18, 9, 37, 39 you will get. 39 by 4 you will write. Then you will take this 15, 17, 18 by 4 you will get. And here you will get 18, 24, 27 by 4 you get. You can convert it into decimals or you keep like this. It will you can calculate this thing and you can put these values. So this is how pooling concept works. Now the last topic that comes is the flatten. Here now there is no role of this example. I will tell you with this particular thing. Now we will take this last concept, that is the flattening. Here we will be using this maximum and average thing only, so that is not that difficult. So what is the concept of flattening here? What is the concept of flattening here? See, the meaning of flattening here is you are trying to convert the value that you got from max pooling or average pooling into the numpy array format, and you will send it to the neural network. So what does this mean? Let's say you got this maximum value as 17, 19, 9, 4. You convert it into array. You flatten it into array. So once you flatten it into array, how it will come? It will come as 9, like this. 19, 9, 4. Okay. Now what will happen? These particular things will be sent as the input layer. This is the input layer. Will be sent to the input layer. From input layer, what will happen? It will go to the hidden layers. Like let's say we are taking 2 hidden layers. So it will go like this. Hidden layers. It will go to both the hidden layers. It will go to both the hidden layers. It will go to both the hidden layers. Here we take the hidden value as 2. And from this, what will happen? It will again go to this particular hidden layer like this, and from that it will generate an output. Okay. So like this. Like from after flattening, you are converting your thing into you are sending it into the artificial neural network. See, there we are using 900 MB, some 3 lakh amount of input you have to send for this. But here how many we have to send? Only 4. Similarly, for 5 cross 5 images, only 4 inputs we are sending. So how much computational power it is saving? So that is why whenever an image concept comes here, you will be using the concept of CNN. So I hope you understood the concept, entire flow from CNN to ANN. And now we will going to discuss the very important topic, that is the backpropagation. Very simple example to make you understand the flow of how CNN and ANN connect together. See, here you have the original input image, correct? Input image. So from the input image, what you will do? You will apply the concept of kernel. You will use the formula, and you will get one particular matrix, new matrix that is formed. And from the new matrix, what will happen? You apply the pooling concept, either max pooling or average pooling that you have done. You will get this particular value, and from this pooling, you will flatten this particular into numpy array, and then you will send it to the ANN. So this is the concept how this particular like for big images also, if you anywhere in the internet you see such kind of images, you yourself can figure out like what he has done. First he has done padding, then convolution, or first he had done convolution, then padding. And this particular kernel where 3 cross 3 we have applied, this process is called as convolution. This process is called as convolution layer. This layer is called as pooling layer. Okay. And this layer is called as flattening. Whenever in the internet you guys see this particular thing, you understand that like here, okay, convolution means kernel technique he has used. Pooling means, okay, he had done either max pooling or average pooling he has done. And flattening. So this is about the particular flow, and now we're going to discuss about the backpropagation. Yeah, so now let's start the concept of backpropagation. So what is the meaning of backpropagation and how will we deal with the CNN point of view? See, backpropagation is the concept where, let's say, here I am using my convolution neural network. Okay, in my convolution neural network, let's say till now in this till here you understood that it's a CNN process, and from CNN it will go here in the process of ANN, neural network process. But you know one thing, like let's say after doing all of these processes, like here after doing all of the processes, your original output should be, let's say, 10,000. Original output, let's say 10,000, but your model, like the entire deep learning, has given you the output as 8,000. Deep learning has given the output as 8,000. So this y hat, we represent it as y hat, we represent it as y. So what is y hat? The predicted value. This is the original value that you should get when you pass the data. Original value. So what is happening here? Your model should give 10,000, but your model is giving only 8,000. So what does this mean? The model has some problem. So what is the problem? Model is occurring a severe loss. So what is loss now? Loss is nothing but the difference between the predicted value and the actual value. We call it as loss. So now what is the loss here? Loss will be 2,000. So, but if 2,000 means it's a very huge loss. Let's say if your sugar value is, let's say, is coming 200, but your model is predicting 130. So the dosage of medicine will change, right? It is not correct. It should give exact 200, or if it is not exact also, it should at least give 190 or 210. Then it is not a problem. But it is giving you 120, 130 value. So that's why, to avoid this problem, we use the concept of backpropagation. So now here, what is the approach that we are following? From CNN, we will go to the ANN. Correct. So now what this is nothing but the forward propagation, where you go from CNN to ANN, is called as the forward propagation, which I write it as FP. So now what you have to do? You have to come back from ANN to CNN. Why? So what is the meaning of backpropagation? From output, you will go back to the output layer, to hidden layer, to flattening, to the max pooling, to the value that you got after multiplied with the kernel. So here what you have to do in backpropagation, you have to update the value from kernel. To update the value from the kernel that we use not to multiply to get the answer, means the kernel is not being updated properly. The kernel values are not proper. So you have to update those kernel values. So this process is called as backpropagation. Now you might ask, like, sir, how are you so sure that mistake is from kernel side? Why it is not from ANN side? See, the mistake might happen from both the sides. Either it might be happen from CNN or it might be happen from ANN. But because in CNN what we are doing, we are trying to get the important information out of the image. But sometimes due to the compression of image, lots of amount of data is been compromised. So that's why the chances of errors will come in the CNN also. In ANN what happens here, we update the weights, right? Here let's say the value, let's say you got in Flatten, we represent it as A. When you multiply it with the W, the chances of weights also might be wrong. So the mistake might happen from both the sides, ANN and CNN. So sir, how to fix these particular issues? So for this, we will take one example and I will tell you how exactly you can able to solve the backpropagation question. And I am sure by using this from 2000 the loss that you got, you will at least go up to 50 or 60, like that you will go. See, if your house price is 10,000 and model is giving 9,950 means no problem. That is not wrong. 50 rupees person can afford. But if your house price is 10,000 and your model is giving 8,000 means 2,000 difference is there. So that difference is problem. So by back propagation you are trying to reduce the loss. You're trying to reduce the loss. This is the major objective of backpropagation. So in coding you see, right, epochs are there, 4 epochs, 5 epochs, 100 epochs. So what are these epochs? Epochs are nothing but number of times you're iterating this process to make model learn more efficiently. In coding you don't need this backpropagation thing. It will, when you do the compile part, there itself backpropagation will take place where you have to pass the optimizer, that thing you will do. But you should know the theoretical concept behind backpropagation. That is important. How it works. That's why now I will take one example to explain what is backpropagation and how you can able to solve the updated weights and all we will going to see in the backpropagation. See, whatever you do in the ANN part, same thing you have to do for CNN part. Same thing. There is no difference. Process will be same. So I will do for the ANN part where I will teach you how you can update the weights using the learning curve. So let's start it. So I will take one example and I will tell how you can do backpropagation. See, here I took this particular example to teach you guys how to do the backpropagation thing. So first step what you have to do, you have to solve this particular question. So first step what you have to do is, you have to calculate till flatten. Okay. See, now what you will do, you will multiply this x with kernel. So here what you will do, here first you will multiply this particular thing with this particular kernel, and then you will multiply this thing with this kernel, then you will multiply this with this kernel and this with this kernel. So after multiplying, you will get the value as new, here I will write z as the new flattened matrix. This value will be 0, -1, -1, 1. Okay, 1 into 1, 1, 2 into 0, 0, -1. So 0 you will get like this. So after you getting this particular matrix that you got, that is here 3 cross 3 and 2 cross 2. How to check whether the matrix you got is correct or not? Same, n minus f plus 1. And here we keep s as 1, let's say. Stride as 1. So n minus means what? 3. 3 minus 2 plus 1 means what? 2. 2 cross 2 matrix we form. Means it's correct. So now what you have to do? Now here you have to apply the before flattening. See, before flattening. Note. Before flattening. Apply ReLU. What is ReLU? ReLU is an activation function which has range of 0 to infinity. Has the range of 0 to infinity. So now what you will do? You will apply ReLU on Z. When you apply ReLU on Z, here -1. Is -1 bigger than 0? No. So if this negative value is lesser than this particular 0, then it will make this value as 0 itself. 0, 0, 0. Is 1 greater than 0? 1. So keep the original value like this. So this is how your ReLU activation function works. So now you have to do the flattening process. So in flattening, what will you do? You convert this particular zeros and then you will send into the neural networks, where let's say this is the input layer. This is the input layer. And this input layer will have some weights W, 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 W. Okay, W1, W2, W. So here I will write about W, W1, W2, W3. Here I write some 3 activations we will make. This, 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 this. So like this we will fill all of the neural networks, and then here you will go back to this particular thing and here you got this thing. Here let's say you got weight, you got weight, you got weight. See, now the value that you got is y hat. So how you calculate the value of y hat? The y hat value is calculated by the weights that you have. This weight, you multiply this weight with this flattened value. So that's why what will happen? You will multiply this with weight into the flattened value. Flatten. That is the z that you got. So the z that you got, flatten. So what does this? So now what? How will you multiply this particular thing? Here we have only 1. Rest 0. If you multiply, there is no use of multiplying with the 0. As if you multiply, you will get the value of 0 only. So now what is the weight? Here we are taking some conditions. Like this particular weights will be 0.5. Learning rate will be 0.1. Original target should be 2. Here we are specifying the problem statement. So now what is the weight here? 0.5 into flattening value is 1. So once you do it, you will get the value as 0.5 y hat. Okay. Now you have to calculate the value of loss. So here I will rub this above part. Now we will fully do on the calculation part. Okay, I will rub till here for now. Okay. Okay. Now what you have to do? You have to calculate the loss here. So loss. So what is the formula to calculate the loss? 1/2 y hat minus y the whole square. This is the formula to calculate the loss. Correct. So now when you do this, when you apply this formula, here what is the y hat that you got? 0.5 you got 0.5. What is the value of the original one? 2. So when you do these calculations, you will get some 1.12, you will get the answer. This is not equal to 0. If loss is equal to 0 means model is perfect. But here loss is there. So there is a problem with updation of weights. So now you have to backpropagate it. So now the backpropagation starts. Okay. So now here I will also rub till this step 1 as it is not that required now. Okay, till we will remove this till here. Okay, this we will remove. Okay, this also will remove. So now backpropagation starts. So now in backpropagation, what I said, you will update the weights. Correct. So to update the weights, you have this formula. New weights is equal to old weights minus this learning rate, we call it as the alpha, minus alpha into dl by dw. This is the formula to calculate the new updated weights. dl by dw is the formula to calculate the new weights. Okay, you know the old value. What you got, the original old value, we keep this as the old value 0.5, but you don't know the value of dl by dw. So how will you calculate the value of dl by dw? So for this we will be using the concept of chain rule of differentiation. So we will be using the concept of chain rule of differentiation. So what is the concept of chain rule? It says, okay, you cannot find the value directly. So what happens if we solve it via indirect approach? That is what chain rule tells. So what does this chain rule tells? See, dl by dw you have, and you know this, you have this particular equation. First equation you have, this first equation you have, and second equation you have. So based upon these two equations, can you form a relation? Yes, you can form the relation. How? I will tell you. See, now let's say here I will calculate the differentiation part. Here we can calculate it as dl by dy hat into dy hat by dw. How, sir? How it came? we will going to differentiate this with respect to w. We will going to differentiate this L with respect to y hat. And now if you cut this thing, you will get the value of dl by dw. So this is how we will do the differentiation. Now to calculate dl by dy, how will you do? Here you will write dl by dy hash. So to calculate dy by dl, you will going to use the differentiation part. So 1 upon 2, here you use this equation to calculate it. Dy dash, what it will come? 1 upon 2, this 2 will come front, 2 into y dash minus y. So this two will get cut. So what will be the value left? Y dash minus y. You know the value of y dash 0.5. You know the value of y, which is 2. If you do it, you will get the value as minus 1.5. Correct? So here you got the value as dl by dy dash. Okay. Let's say I am calling this as equation number 3. And now the last thing is you have to calculate this dy by dw. Then this chain rule will work. So now what here in the below I will do. So now here I will write dy dash by dw. So here what will happen? dy by dw of w into flatten of this flatten. Let's say here I will represent this particular flatten as, let's say, a. So we will write this as a here. So when I write this particular a here, so this will get cancelled. You will get the value as a here. What is the value of a? You will get the value as, what is the value of a you got? Yeah, you got the value of a as 0.5. So I hope you understood how you got the value of a as 0.5. You differentiate it, you will get the value of a. Because here if this particular thing is 1, this weight is 0.5, when you differentiate it, what will happen? This one will get cancelled and you will only left with 0.5. So now you got the value of dy by dw. This value will be 0.5. So here I will write dy dash by dw is equal to 0.5. So now what you will do, your problem has been solved here. You applied the chain rule. Chain rule is successful. Now what you will do, you will just substitute the values here in this equation. That is, in place of dl by dw, you can directly write it as dy dash by dw, dl by dy dash into dy dash by dw. So here you know the value, minus 1.5 into 0.5. What will you got? That you will get it as minus 0.75. This is the value that you got of dl by dw. Now substitute this. Here I will write this as fifth equation. This I will write as 6. Substitute value of 6 in equation number 5. So once you substitute the equation of 6 in 5, then what will happen? With learning rate as 0.1. So what will be the old? So old value you have 0.5 minus alpha is what? 0.1 into minus 0.75. So once you do it, 0.5 plus 1 by 10 into 75 by 100 if I do. So you will get 0.5 plus 0.075. And once you take the sum of it, you will get the value as 0.575. This is the new updated weight value. What? This is the new updated weight value. So like this is the process of calculating the new weight from the old weight. So this is the value of W new. W new will be this. So what we did, we calculated till flatten, then we use this equation, and after using this equation what we did, we calculated the loss of both of it, and then we used this formula where learning rate we kept as 0.1, and then we substituted the value. and in this way you can able to solve the back propagation for CNN as well. Same approach, like here for every kernel value, let's say if kernel value is 1 2 3 4, in first kernel value we'll write dw1 by d, like how we calculate dl by dw1, you'll use the same chain rule equation, dl by dw2 for second, dl by dw3, dl by dw4, like this you will update the values of kernel. So this is how you do back propagation in CNN and ANN. I hope you understood these concepts. Now we will going to see the coding in Python. So that's it, the theory. We studied the concepts of convolution neural network, where we studied about the padding, stride, pooling. Then we also studied about the flattening layer. So all of these things we studied, and we also studied about how the backpropagation takes place in the CNN. So now it is our time to implement the concepts that we studied using the code. So the first important thing that you have to know is the dataset. So in the dataset, we are going to use the MNIST dataset. So what is this MNIST dataset? MNIST dataset is the number dataset. Like we have numbers like 1, 2, 3, 4, 5, 6 in the form of image, and you have to create a model in such a way that uh, by seeing the image it should able to detect like what number it is. So that is our major objective of using this particular implementation. So we will be using this MNIST data set, and one so here we will start the implementation. First step that you have to do is you have to install the modules that are required. Okay, so the modules that we are going to use here is NumPy, Matplotlib, and TensorFlow, means Keras. In simple words, we'll be using Keras. So here I will go to my command prompt. I will type pip install numpy, matplotlib, and TensorFlow. If I click on enter, see the requirements are already satisfied, means these three are already installed in my systems. So this particular step one has been completed. Step one has been completed. Now what you have to do, you have to import the modules. You have to import the modules. So what are the modules that we're going to use? We are going to use import numpy as np. Okay, we will be using import matplotlib.pyplot as plt. We are creating the alias name, and we are going to use TensorFlow. From TensorFlow dot keras import, what you have to import, you have to import the layers option, you have to import the models option, and you also have to import this one, models, this one, dense and datasets, because the MNIST dataset comes from the TensorFlow itself. It's a TensorFlow dataset we'll be going to use. So these are the modules that we'll be going to use. Okay, now next step we have to do is you have to load the dataset. Load the dataset and do pre-processing, that is normalizing and reshaping. So these are the two things that we will going to do here. So like if so what I have to install, I have to install the dataset. So here I will write datasets dot, what dataset I want, I want MNIST dataset dot load underscore data. So what does this mean? So it will return you the two tuples. This data set, once you use, it will return you the two tuples. What are the two tuples? It will return, in the first tuple it will return x train y train, and it will return you x test y test, x test y test. So this is how you can able to load the data set in your particular system. So if I click on, if I go to command and if I use this particular data sets, means this data sets has been used here. So now next step that you have to use is you have to do pre-processing. So here I will do here itself. So in the pre-processing, what you do, you normalize the x train and x test, so that y train and y test will be converted from 0 to 1 range. So now we will do normalization. So what is normalization? Normalization means by default your values are in the range of 0 to 255. So what you will do to convert it into the range of 0 to 1, what you have to do, you have to divide it with 255. divide it with. The benefit of normalization is the training process will become faster and the accuracy will also be improved. That's why the this particular normalization is important. So now if I do extrain here, so in the extrain what I have to do, first I have to reshape this particular thing, because the input data of extrain xtest should be same, then only it will work. So here I will do reshape, and here in the reshape I will do -1. So what is this -1? This -1 means automatically based upon the neighborhood images, based upon the nearby images, this particular extrain will take the shape automatically. So that's why we will be using -1 here. So in the -1 we will give the shape here. We want it to be 28 comma 28 comma 1. Means you want your image should be 28 cross 28 with one color channel. One color channel means what? Black and white you want. That's why we are using one here. If I write 3 means it will convert into color 1. So that is why this is very important, reshape 1. So now what you have to do, you have to divide it with 255.0. Then only it will convert from 0 to 255 to 0 to 1. Like if you divide 255 with 255 into range of 0 to 1, its original range is 0 to 255, we convert into 0 to 1. So similarly we have to do for x test also. So x test dot reshape, say -1, same shape we have to use, then only it will give you good accuracy, divide by 255.0. So once this particular extrain and x test have been done, now you have to build this CNN. Now you have to build CNN. Build CNN. So now what you have to do, for I'll create one variable, and in that I will use models dot sequential. Okay, so what is this meaning of sequential? To create a particular neural network, first you have to create in, you have to use like you want from input layer to hidden layer to hidden layer to output layer you want it. So to achieve it you have to use this sequential function. So in the sequential function what I will use here, I will create some here only I will uh, create the input layer, hidden layer, and we will also do the output layer. So all things we can do here itself. So for this how you have to do, now first step is you have to create the input layer with and with specify the size. Sorry, you have to apply the convolution layer first. Okay, so how to apply the convolution layer? See here we use this particular model, so this layers we will use this layers. So layers, in the layers what we have to do, in that we will use conv2d. Conv2d. So what is this conv2d? It's convolution layer for two-dimensional objects. For that we will be using conv2d. Conv 3D means we'll use it for three-dimensional. So in this what you have to do, you have to specify the number of filters. So here I will write, if I go if I go here, I have to specify the number of filters that I want 32 filters to be there. Now you have to specify the kernel size. So kernel size I will going to give is 3 comma 3. 3 comma 3 kernel size I'll going to give. Then what you have to give, you have to give the activation function. So here I'll give activation function as relu. And next thing is I also have to give the input shape. So the input shape will be 28 comma 28 comma 1. You want in this shape 28 comma 28 comma 1. So you want in this particular shape. So that is why your this particular place component plays a very important role. So these are the specifications you want, first thing. Now after doing this what you have to do, you have to do flatten, because you have applied the particular filter matrix you applied, you have given the input shape, you have find the filters. Then what you have to do, you have to do max pooling. Max pooling 2D. Max, it should be P capital. Yeah, it should be P capital. Max pooling 2D. And in the 2D, what you have to pass in the max pooling 2D, you have to pass this particular shape. Like max pooling means once you get this particular, after you do the 32 filters, 32 filters with 3 cross 3, you will get some output. Then you will use 2 cross 2 matrix to further compress the image, at the same time preserving the important information in the image. For that, max pooling plays a very important role. And once this is done, then you will do flatten. So flatten means converting into the numpy array we'll going to do. So this is how you can able to do it. F should be capital. It should be and layers dot flatten. Now convolution layer concepts have been applied, where you have applied the convolution layer where you use 32 filters, and this particular concept has been done. So here I have to put comma, then it is correct. Now what you have to do, now you have to apply the ANN. Like in the last lecture itself, in the theoretical stuff itself, I taught you how you can able to implement, like connect this ANN with ANN. After flattening, you have to do it. So for this, what you have to do here, you have to do layers dot dense. So in the dense layer, what I will do, first I have to pass the uh, number of layers that I want. So here I will pass, let's say 32 layers I will pass, let's say. And in the 32 layers, after passing 32, what I have to do, I have to pass the activation function. Here activation I will pass relu. Then what I will do, I have to give my another hidden layer. So here I will give 16, and here I will give relu. And now I want to create my output layer. See here, since we are not using the single or multiple or the thing, we are using the multiple categories, 1 2 3 4 5 6 7 8 9. So here we are using the categorical cross entropy we will be using. So that's why in output layer you have to give some layers but not one. If you give one, means it will become the binary output, like 0 1 0 1, like that it will give the output. So here we'll pass the activation 10, and here we'll pass the activation as softmax. Okay, for this kind of data we will be going to use the softmax activation function. Now what you have to do, you have done the CNN also, and also we have built it the ANN also, and ANN also we built. So now what we have to do, we have to just compile and train the model and fit the model. Fit or train both same only. Now what you have to do here, you have to do compile. So model dot compile. In compile, what you have to pass, you have to pass the optimizer. So in optimizer, here I will pass the Adam optimizer that I will going to use. Then the loss function that you have to specify. Here in the back propagation, I taught you the what is the loss function, and how it plays a very important role, and all I taught in the back propagation thing. In the theoretical stuffs I already covered. So here we will be going to write sparse categorical entropy will going to pass. Sparse categorical cross entropy will going to pass. So now what you have to do, and you have to use the matrices. So what are the matrices? METRICES. If you use METRICES, it will give you the error. That's why we will be going to use METRICS, and here we're going to pass the accuracy. And after passing this particular thing, your majority, you compile the model. Now you have to fit the model. In the fit, where you have to fit the model, X train, Y train, and here you have to pass the epochs. So how many epochs I want? I want, let's say, three. I want 4 epochs to be done. So after passing the epochs, we have to give the validation data also. Well, like after doing epochs, what are the conclusions that you are getting? So in the validation data, we will going to pass it as like based upon what you have to pass the validation data. So you're going to pass X test and Y test. So validation should be based upon the testing data. That's why we are passing this thing. So now after compiling the model, then what we have to do, then you have to evaluate the model. Based upon the accuracy, you have to evaluate the model, and you have to test the model also. So for this, what you have to do, we have to check the accuracy. So what you have to do, there is one function called as evaluate. EVALUAT. What does this evaluate function do? This evaluate function will return it will evaluate based upon the testing data, and after evaluating with the testing data, it will return you the two things, that is the loss and accuracy. Okay, this accuracy. So now if you want to check the accuracy, then what you have to do, you have to check the accuracy score, and here you will pass the test accuracy. Okay, and if you want to check the loss score, then you can pass the print, we will pass the loss score. So here I will do the loss score, here I'll write test loss. Now after evaluating the model, then now what step you have to do, you have to like you have to test it on a image, right? Test it on a image. Okay, so so how to test it on a image, how to test it on an image. So what I will do here, I will write index. So in the index, what I will do, let's say I am passing the particular input, or let user pass the particular input. So let's say here I am passing, let's say index as I will pass 7, let's say I'll pass. I want to check what is present inside the seventh index value. So to test it on image, what you have to do, you will pass the particular index. Then what you have to do, you have to you have to test, in that you have to pass the seventh, this index option. Means what, in the xtest folder or in the xtest data, you have to print the seventh index value, you have to display the seventh index value. That's why we are using this concept. Now what you have to do, you have to plot it. So here I'll write plot it. So for plotting, what library we will use, plt.imshow function we'll going to use. In the imshow function, what we have to pass, we have to pass, so you have to pass the reshape also. So here we are passing 28 comma 28 we are passing. And then what you have to do, you have to pass the cmap. So here cmap means gray color, means in the black and white format you want to plot it. Then here we will give the title also. What title we will give, here we will give the title as actual image. Actual image. Actual image. So what is the actual image? This particular y test of index will be the actual image. Y test of image, sorry, y test of index. Like what it will do, in the y test folder, in this, what is the seventh index, what will be the value of the seventh index, it will just give you the value. So that is why your title also plays a very important role. And here we will turn off the access, I don't want access. And here I want the plt.show function I will do. So once I do the show function, it will display the particular image here it. So now let's say if I implement it, python cnn.py, if I do it, then what it will do, let it load here. See, here the training has been started, epochs, here epochs have been started. First epoch it is doing the training. I will make it little big so that you can able to see it. The second epoch also started training. In the first, the accuracy is 84, second 97. Why the loss function is reduced here? Because the back propagation has been applied. First time the process has done, then it back propagates, it will update the weight, again it will do the thing, then again it will come back, it will again do the thing, it will again come back, it will again do the thing. So now here see, here you see the image is 9 and it is showing the actual image is 9, means our training has done successfully. And now here you have to predict it. So training has been done, evaluation has been done, and you tested it on the image. Now you have to print the number. To print the number, so to print the number, what you have to do, you have to do predictions. So for the prediction, what you will do, you will write model dot predict function, and in the predict function, what you have to do, you have to do the for image you want, but in the reshaped format. So 28 comma 1. So in the one color channel, you only want to print only one particular image, and 28 comma 28 means 28 width, 28 height, and one color channel image you want to print, that is black and white image you want to print. So finally your prediction label, what is the prediction label? So prediction label is nothing but the value that you are going to print. So for that, what you will do, here you will write np, like in the, you are having the argmax function, it will return the maximum correct value of the particular predicted value. So for that you will use the prediction function. And then what you will do, print, you will print the here you will print the actual image value, actual image value, actual image value. which is nothing but your this y test comma y test of index. Here we're going to pass, and if you want to print the predicted value, and you see both of the values will remain the same. Here I will write a prediction label, and now you see here the accuracy score is there, loss score has been mentioned here. Here I will remove this particular. I'll quick click on the quit, and now I'll again refresh the particular thing, python cnn.py. You will see the process. See, first first epoch is been done, second epoch has been done. See, in the first epoch it has given 80.79 accuracy, because model has been trained, it has given some particular accuracy, and that accuracy of the model, like once that is not good accuracy. So what model is doing, it is doing the back propagation, where it is updating the weight, then it is again doing the forward propagation, it is giving accuracy. So like this it is doing for 4 times. That is the concept of using epochs. See, actual image is 9, and the image is also showing the 9, means the prediction has been done correctly. Now if I go here and if I click on the close option here, and now if you see this particular thing, see, the actual image is also 9, predicted value is always 9. That is what I told, means the prediction that our model has did is 100% correct. So to print the number, or to predict the number, to predict the number, we will be going to use this particular approach. So I hope you understood the how we can able to do the particular implementation of cnn using keras. So first we loaded the dataset, then we had a normalization, where instead of giving the range from 0 to 255, we converted the range into 0 to 1, so that the training process will be fast and the accuracy will be good. And then here you have to do reshaping, because we want every time to be use this same value, like 28 width, 28 height, and one color channel. Then we have built cnn and ann, where first we built the cnn, then we put the ann layers, where we also specified the output layer. Then we fitted the model and compiled the model, where we used the sparse categorical cross entropy, because here output is 1 2 3 4 5 6 7 8 9 10, only 10 are there. So that's why it is important to use sparse categorical entropy. But if you are using the normal 2, if you have only 0 and 1, then use for binary cross entropy. Since it is having more than 2, that's why we are using sparse categorical entropy. So then you have to use you have fitted the model, where we have done the 4. If you do the more epochs, the overfitting also will be increased. That's why for now I specified the 4. Then we evaluated the model, then we tested out in the image, and we also checked whether the particular thing is working properly or not. So we'll test with one more image. Here I'll pass 9, let's say. Here I will again implement this particular python cnn.py. So once you implement this particular thing, again the training will takes place, and it will give you the accuracy. See, now you see it is 84%. Every time the weights will be different. How the model train takes place, it will be different. So that is why it is important for you guys to know that every time this accuracy score won't be same. So once these epochs are happening, it is loading here. See, now it is giving 9. See, actual image is 9. So ninth index is the 9 image. So now if I quit this particular thing also, here you are getting 9 only. So here if I quit this image also, you will be getting 9. So it means our model has trained correctly. So this is our accuracy score, this is our 9, and this is how the procedure of entire this uh, implementation of keras. So I hope you understood this concept of implementation in keras. So I already explained you the theoretical concepts. Now it's important for us to know the practical concepts, so I also implemented it. So thank you so much for providing me this opportunity.